How's it, hard hat heroes?
All right, good afternoon, ladies and gentlemen. I'm Andre Dupree. Thank you for the introduction. And ladies and gents, I don't know if you heard much of the video, but my presentation this afternoon is going to be about technological hazards in the 21st century and the way forward. So, as stated in the video, I don't know if you heard it properly, but as stated in the video, it doesn't really matter whether you are an advocate of technological change or whether you are a critic of technological change. What is and what should be abundantly clear to all of us present here is that urgent technological health and safety risk assessments are needed. Ladies and gentlemen, and that process basically starts by identifying technological health and safety hazards properly. I'm going to shortly go over to what hazards are according to OHS, and I'm going to look at what hazards are in terms of ISO 45001, and then I'm going to give you a third alternative of what a possible hazard is. I'm going to tie it in with technology, and we're going to look at what are the ways forward. Before I do so, I just want to point out something to you as well. When we look at the process of conducting risk assessments, risk assessment basically is a step-by-step process that we follow with an end result in mind, and that end result is normally to try and eliminate whatever risk we've identified or to try and mitigate or manage whatever risk remains. Now, the thing is here that if you skip a step in the process, or if you deviate from the process, or you will find that your results will probably be flawed. The same thing would apply when we speaking of hazards. I think coming from an occupational health and safety background, I could probably ask any one of you what a hazard is, and some of you will come up with specific examples, some of you might come up with specific definitions, but in reality, we need to agree on what hazards are. So if you don't get the hazard right, at the end of the day, your calculated risk will be flawed and your control measures will not make sense. So it is extremely important, especially in the 21st century, as we are moving forward with emerging and converging technologies. Alright, ladies and gents, so that is basically the Occupational Health and Safety Act definition of what a hazard is. OSHA, our Act 85 of 1993, basically stipulates that it is the source of or the exposure to danger. Now, I don't have a problem with a hazard being defined as the source of danger. If you then go look at the definition for what a danger is, it then states is that something that has potential to cause harm. I don't have a problem with that part of it. So if you've had, for example, a chemical, that's the source of the danger. You have a fume, there is the danger. That I'm totally fine with. Same thing, machinery, there's the source of the danger. Noise, there is the danger. But the problem that I have with this definition is the word exposure. I want to make sure that we all get it. Ladies and gentlemen, hazards are not exposed to other hazards. And I've listened to several people today referring to obviously exposure. We like to say people are exposed to high levels of noise. People are exposed to radiation. Let me make it clear, hazards always interact with other hazards. And it's when they interact with other hazards that different levels of health and safety risk is created. Hazards are not exposed to other hazards. If you think about something like, for example, let's take noise. If you talk about exposure is basically a one-sided vulnerability. And that's not what a hazard is. There's an interaction. So, ladies and gentlemen, if you look at something like noise, for example, what is noise? It's sound waves that interact with our ears. There's the interaction. The same thing with radiation. These are particles that interact with our cells at the cellular level, and that's what basically causes cancers and things like that. It's not exposure. So I want to just say that I do not agree with the exposure part, but that it is something that hazards interact with hazards. A little bit later on in the conversation, I'm going to talk about the characteristics of health and safety hazards, and I'm going to come back to the interaction part again. Ladies and gents, then if we look at interaction there, it says usually interaction refers to something that is given, felt, or done in return. So when hazards interact with other hazards, it is something that is given, felt, or done in return. There's some other reciprocal exchange of energy when hazards interact with other hazards. And again, like I said, exposure basically refers to a one-sided vulnerability, which hazards are not. Ladies and gents, then if we look at the ISO 45001 definition of a hazard, it follows similar lines to the OHS definition. So it basically refers to a hazard as the source with potential to cause injury and ill health. So the injury and ill health, those are the dangers according to our OHS definition. So again, I don't have a problem with that. Where I do find a little bit of a challenge is in terms of clause 6.1.2 of ISO 45001 that is very ambiguous and that is open to many interpretations. So a lot of people in industry will tell you that situations, conditions, and acts, human acts, are also hazards. Working at height is a hazard. I can tell you right from the beginning that working at height is not a hazard. Poor housekeeping is not a hazard. So anything, a person not wearing PPE, it's not a hazard. So it's a bit ambiguous, ladies and gents. As a result, like I said, many safety practitioners assume that sources, situations, and acts are hazards, which they are not. Ladies and gents, now, what I would like to do is to offer you a third alternative of what a hazard could potentially be. But before I get to this definition of what a hazard actually is, I want to look at two specific things. The first one is I need to look at the types of hazards that we can find in our workplaces. This must not be confused with your classification of hazards. I'll get to that just now. And I want to look at the characteristics of hazards. And then once we know what the characteristics of a hazard is, then we should be able to define it properly. So let's first of all look at so I'm going to look at first of all, that's basically just a confirmation of what I just said now. So we're going to look at first of all the types of hazards. And I'm going to start off with the first one. We have single hazards, compound hazards, and multiple hazards. And ladies and gents, again, like I said, do not confuse this with the ISO 45001 classification of hazards, where they group certain hazards together as physical hazards, chemical hazards, biological hazards, etc., ergonomic hazards, etc. This is not the same thing. So if we go and look at what a single hazard is basically any object that is a pure element on the periodic table of natural elements. A single element on the periodic table of natural elements. So we're talking about the examples that I've got here: pure iron, pure lead, pure oxygen, pure nitrogen. Anything that is a single element on the periodic table of natural elements. If we now move on to compound hazards. Compound hazards basically is any time you take any of these single elements on the periodic table of natural elements and you either chemically or physically join them together, you create what we call a compound hazard. So if you take water, for example, H2O, 2 parts hydrogen, 1 part oxygen, and there you have a compound hazard. So just to look at the definition there, a compound hazard is created when 2 or more of these elements on the periodic table of natural elements are either physically or chemically joined. And the examples I have there include water, paint, metal alloys, etc. The third type of hazard we have, ladies and gentlemen, are our multiple hazards. Now, multiple hazards is any time you take any single or compound hazard and they interact with other hazards on the basis of their combined characteristics, you basically have what we refer to as a multiple hazard. Examples I've given there in line with our technology discussions that we are having. Things like computers, mobile phones, vehicles, drones, etc. But just a simple other example that I can give you. Let's say I can take a metal alloy, I create a metal pipe with it, and I take a paint, which is also a compound hazard, and I paint the pipe. I'm sitting there with a multiple hazard at the end of the day. Now, the important here is they interact with other hazards on the basis of their combined characteristics. Just to summarize, ladies and gentlemen, single hazards, compound hazards, and multiple hazards. Those are the 3 types of hazards that we find in our workplaces. And that is not to be confused with your classification of hazards. All of these basically, on the basis of their combined characteristics, are often grouped together as physical, chemical, biological, ergonomic, psychosocial hazards. But these are the three types of hazards that we find in our workplaces. Now, looking at multiple hazards, ladies and gentlemen, or maybe even specifically the single hazards, if you look at the mass of a human body, I don't know if you're aware of this, but about 99% of the mass of a human body consists of 6 of these elements that we find on the periodic table of natural elements. So some of you might already get where I'm going with this now. Okay, about human beings. So what are the characteristics then of these single, compound, and multiple hazards? So let's move on to the characteristics. Ladies and gentlemen, so there's the first one. All hazards consist of matter in the form of a liquid, solid, or a gas, and one of the later ones that we added recently is plasma, and that ties in with technology. Now, a lot of plasma that we find out there. So all hazards have matter. They consist of matter. All hazards are governed by natural laws. There's another characteristic that I'm going to bring in shortly, where we're going to talk about the potential and kinetic energy of hazards. Now, this ties in with that conversation. All hazards are governed by natural laws. I'm referring here to Einstein's theory of relativity. I'm referring to Newton's laws of motion. They are governed by natural laws. All hazards are governed by natural laws. Another one, all hazards have symmetry. Ladies and gents, it's a science on its own, but there's different types of symmetry, but all hazards do have symmetry. All hazards have weight. All hazards have volume and size. All hazards have density. All hazards have a shape. All hazards have a surface or a texture. All hazards have potential or kinetic energy. Speaking of those natural laws, meaning here that a hazard can basically either move on its own or it can be moved by another force. Hey, they have potential or kinetic energy. All hazards interact with other hazards. You remember earlier I said to you that they're not exposed to other hazards, they interact with other hazards. And it's when they interact with other hazards that different levels of health and safety risk is created. Right, ladies and gents, so let's see if we can put this into a definition. If you look at all of these characteristics, one of the key things that I've taken from all of this is that hazards are tangible objects. You should be able to touch them. Now, so let's try and put it together. Hazard is basically then a tangible object that has the potential to cause harm because of its ability to move on its own or to be moved by another force. This characteristic of a hazard is also often referred to as the closing and collision potential of hazards. Right, ladies and gents? Now, where does this leave us as human beings? Ladies and gents, before I get to the conversation about human beings, let's talk about any tangible object. Let me take this table for example. Let's quickly look at the characteristics. Does this table have the characteristics of a potential hazard? Does it have a size, shape, weight, density, surface or texture, volume? Can it move on its own or can it be moved by another force? Therefore, it clearly is a hazard. Now, we are in agreement there. It has potential to harm. I can walk past it, I can bump myself, get a little minor bruise, or I can climb onto this table to try and change a light bulb, the table can collapse, I can end up falling. You agree? So you're saying I'm fat, you know? Alright, but it will probably collapse under my weight. Now, alright, ladies and gentlemen, but let's look at human beings. Do I have a shape? Size? Volume? Weight? Surface or texture? Density? Am I governed by natural laws? Can I move on my own or can I be moved by another force? Yes. Therefore, ladies and gentlemen, I am a hazard. And that is the one thing that most of our health and safety practitioners do not get. Unsafe human behavior are not hazards. Human beings are hazards.
Right? It is not the table that will tell me, hey, when I can climb on me. It is this winner that will decide I want to climb on that table. Because, ladies and gentlemen, human beings have one additional characteristic that all these other hazards do not have. What is that? We have a mind of our own. Now, and that makes us the most dangerous hazards of all. We are more dangerous than anything else, ladies and gentlemen. And I'm going to get to some statistics just now that will back me up. If we go and look at why we have incidents in our workplaces, is it because of unsafe conditions and situations, or is it because of unsafe human behavior? Statistics will back me up. But human beings are hazards. Just to summarize this, human beings are hazards. Human acts, situations or conditions and departures from the normal are not hazards. So, for example, working at height would not be a hazard. It's not a tangible object. Doesn't meet the characteristics of a hazard. It is a hazardous task that's being performed. But when you look at working at height, I need to go and look at the tangible objects that are there. The roof, the ladder, the human being, the hand tools, the portable electrical tools. I need to go and look for those tangible things that would be there, that human beings can interact with, and that will create different levels of health and safety risk. The similar thing with things like situations and conditions. Situations, not all situations has the potential to harm. Not all situations are unsafe. So therefore situations and conditions are not hazards. Departures from the normal, by saying somebody is not wearing PPE, that is not a hazard. Another one that I find often in industry, people will tell me, okay, cool, we're working with ladders, but now for me to state that there's some sort of danger, I need to point out to you in my risk assessment that this is an unstable ladder or that this is a defective ladder. So yes, a defective ladder is indeed a hazard. But what about ladders that are not defective? Are you telling me that that ladder does not still have potential to harm? It still has potential to harm. So ladies and gentlemen, by stating something is defective or damaged or faulty does not make it a hazard. A departure from a normal. The ladder is a tangible object, can either move on its own or be moved by another force, and that's how it creates different levels of health and safety risk when human beings are interacting with such ladders. So what is the way forward for us as human beings when we interact with these emerging and converging technologies? Ladies and gentlemen, I don't know if there's any of the speakers this week that are going to talk a bit more about technologies, but it's a scary thing. Now, if you go and look at a lot of the advocates for technological change, they will often tell us how technological change can benefit us as human beings. Now, and they focus very much on how this technology could potentially benefit us in various fields of study. But the thing is that these advocates of technological change are often ignoring one thing. They often work from the assumption that the human beings that will use this technology are good people with good intentions. And the reality, unfortunately, is that not all human beings are good people. Not all human beings have good intentions. Human beings, in our own very nature, we are negligent, we are arrogant, we are ignorant, we are stubborn, we are forgetful, and there's a whole bunch of things that I can throw into the mix. So when you are an advocate for technological change, you just focus on how much the technology can better our lives, you are forgetting one thing. It will be human beings that will be using these technology. If you look at critics of technological change, the same thing applies. They will often be these people that will tell you, yeah, but we need to be careful. We need to be careful about the AI and machine intelligence and quantum computing. We need to be careful. Because at some point in time, through something like machine learning, these robots or machines or whatever we've created will be able to replicate themselves. They will surpass our ability to create, and they've got all these doomsday prophecies, and they also forget that it will be human beings that will be creating, that will be using the technologies of the future. The sad thing is, yes, we do have these things. I know that there are people that are already making up. People like Elon Musk are already warning. They're saying, listen, if you take the ultimate software and the ultimate hardware. We take AI and the advancements in technology that we have currently with artificial intelligence, and you take quantum computing and you put these two things together, we are in dangerous territory. So there are already people pointing this out. But what a lot of people tend to forget, that all of this technology will be used by human beings. And it's not the technology so much. Yes, the technology does have potential to harm, but the bigger risk are human beings. I don't know if any of you are following the war in the Middle East, but there's one thing that I saw on the news a day or two back, where pilots that are flying in those areas are reporting that their navigational systems are getting jammed. Now, this is something that a lot of airlines will tell you it's impossible. But yet, a lot of airline pilots are currently telling us that as they fly in the areas of Iran, Iraq, Syria, Turkey, Israel, their navigational systems are getting jammed. Now, it's not the technology, it's human beings. So technology in the hands of human beings can be a very scary thing. To summarize everything, if one considers that approximately 88% of all workplace fatalities, workplace incidents are caused by unsafe acts in our workplaces, that statistic basically backs up what I just said to you, that human beings are the biggest hazards that we have on planet Earth. So it's backed up by the statistic. Now, ladies and gents, keep in mind, statistics change. Now, it's not a constant thing. But that's a figure in the 80% ballpark. It's a figure that's often flaunted and put forward as a statistic for unsafe human behavior. So 88% of the time when there's an incident on site, it would not have been caused by the technology. It would have been caused by a human being. So wrapping up things, what we need to do going forward is we need to have human beings at the forefront of all our technological health and safety risk assessments going forward. We need to look at how human beings will be utilizing the technology going forward. Just a little bit of food for thought. These are just two quotes. The one is from a gentleman called Dick Boston. He's a philosopher, and he's obviously one of those critics of technological change. And this gentleman then said at one point in time, machine intelligence is the last invention that humanity will ever need to make. So Nick is of the opinion that at the moment machine intelligence can exceed our abilities, we are in dangerous territory. And then the great man himself, Albert Einstein, technological process is like an axe in the hands of a pathological criminal. I know that a lot of people that are pro the right to bear arms will often tell you guns don't kill people. People kill people. So it's not the firearm that will be negligent. It's not the firearm that will just simply kill a person. It's a human being using the firearm. And I think this is in line more or less with what Albert Einstein has said here as well. I think he understood that yes, we have an axe, a hazard, and we have a human being that's a pathological criminal. And there's your bigger risk. It's the human being, ladies and gentlemen. I want to leave you with that comment. Thank you for your time. Thank you for listening.